My dear students, first of all, I would like to greet everybody, and I would like to introduce myself. My full name, Yusifova Jamila Yusifova. I am an assistant of professor of Azerbaijan Medical University at Pharmaceutical Chemistry Department, and today we'll begin to study all of the lectures of Pharmaceutical Chemistry 2 and Pharmaceutical Chemistry 4. In accordance to our program, the first topic of Pharmaceutical Chemistry 2 is adamantane derivatives and terpenoids. You can look at the first slide, the name of the first our topic, the derivatives of adamantane and terpenoids. The second slide, you can see the full information about this first slide. For example, the derivatives of adamantane, midantane, rimantadine, glutantane, mimantin, bromantan, adopramin, bromantadine, vildagliptin. Two monocyclic terpenoids include menthol, validol, terpene hydride. And in this topic, we'll also speak about asymmetric synthesis. And we speak about stereochemistry problems, stereochemistry questions, and we speak about using physical and chemical methods of analysis for a definition its quality. And to bicycle terpenoids belong camphor, bromcamphor, sulfocamphocayine, and to tetraene terpenoids belong ricinols and its derivatives. And also we speak about stabilization of these medicine forms. Let's begin to look out the derivatives of adamantane. The two derivatives of adamantane belong the preparation which have antiviral properties, and in medicine are used as antiviral remedies. And you can see the general structure of these preparations, and you can see that this adamantane looks like diamond. And adamantane, the Greek word, and it means diamond. All of them, the most of the adamantane representative received from adamantane, and when bromination with bromine water, form 1 brom adamantane and hydrobromic acid. In this case, we receive 1 amino derivative of adamantane. When we react 1 brom adamantane with amino derivatives, we receive 1 amino derivative of adamantane. And 1 amino adamantane hydrochloride is called midantane. Einen name of midantanum Latin name of this preparation, and einen name of this preparation amantadine hydrochloride. And you can see that this preparation is used as medicine as hydrochloride. The next preparation, rimantadinum hydrochloridum is Latin name. Rimantadine hydrochloride is INN name. And you can see the structure of this preparation, and you can see that chemical name of this preparation, alpha methyl 1 adamantyl methylamine hydrochloride. When we speak about synthesis of rimantadine, we see that rimantadine received from adamantyl methyl ketone, and you can see the structure of this compound. Adamantyl methyl ketone with formamide form aldehyde structure, aldehyde compound, aldehyde nature compound, and with hydrochloride acid form remontadine hydrochloride. The next preparation, gludantan. Gludantan used in medicine as base without it doesn't use as hydrochloride, and in the structure there is the rest of glucuronic acid. Therefore, the name of gludantan, glucuronide of 1 amino adamantan, or other name glucuronide of midantan. The next preparation, memantin, acatinol memantine. The name of this preparation, acatinol memantine, and you can see in the 3 and 5 position in this structure, dimethyl group, and the name of memantin, 3,5-dimethyl 1-amino adamantine hydrochloride. This preparation has antiviral activity. This preparation, midantan, memantin, gludantan, also used against Parkinson disease, anti-Parkinsonic activity. When we speak about physical characteristics, physical properties of this preparation, you can see most of them white crystalline powder, maybe light yellow crystalline powder, for example, gludantan, and some of them has bitter taste, for example, midantan, remontadine has bitter taste. Gludantan has no this taste, and gludantan, for example, middle soluble in water, but midantan insoluble in water, and remontadine also middle soluble in water, and midantan freely soluble in alcohol, but gludantan little soluble, slightly soluble in alcohol, and remontadine insoluble in alcohol. When we speak about identification, we must look at the structure of this preparation. For example, gludantan had the rest of glucuronic acid, therefore gives reaction for glucuronic acid. But first of all, we must heat this preparation with mineral acid, and at the end of reaction form midantan and glucuronic acid. Glucuronic acid must be shown as these two forms, and we can see that in the structure there is aldehyde group, and you know that aldehyde that compounds which have aldehyde group gives the reactions, color reactions with Fehling reagent, gives silver mirror reaction and reaction with Nessler reagent. At the end of the reaction with Fehling reagent form red precipitate. In the end of silver mirror reaction form gray precipitate of silver. Fehling reagent red precipitate of copper 2 oxide or copper 1. Nessler reagent potassium 2 hydroargon iode form at the end of reaction form black precipitate of hydroargon. In the second reactions for aldehyde groups, and the first reaction, glucuronic acid during oxidize forms adipenic acid. When we speak about midantan, we must say that with sodium hydroxide solution, heat, and at the end of reaction form ammonia, and you know that ammonia we determine with different ways. For example, with smell, with wet red litmus paper changing blue color, and with Nessler reagent also we can determine ammonia. The second reaction dissolve in water and filtrate. When we add 5% to nitroindendione 1,3 from yellow precipitate, and also the third reaction for midantan gives reaction on chlorides. When we speak about remontadine, in medium of acetone and sodium carbonate gives purple color with sodium nitroprusside, and it's a legal reagent. And a second reaction gives reaction on chlorides. When we speak about assay, all of these preparations are determined by non-aqueous titration and titrant perchloric acid, H-chloro4, H-chloro4, and indicate a crystal violet. Most situation we titrate until yellow color. And I said about usage of this preparation antiviral remedy, and if we speak about remontadine is used for the prevention and treatment of influenza. If you remember, on our second slide, we also say about bromantan, adapromine, tromantadine, and vildagliptin. Bromontadine improves immunity and body resistance. Tromantadine has antiviral activity against herpes simplex and herpes virus. All of the herpes virus. Vildagliptin, it's hypoglycemic remedy and is used during diabetes of the second degree and for treatment of this diabetes. When we speak about adapromine is used against influenza A and B types of influenza. Now we speak about terpenoids. Terpenoids are the derivatives of terpenes. Terpenes have in the structure only carbon and hydrogen, and the main part of the terpenes, the molecule of isoprene. Isoprene, the structure of isoprene, carbon 5, hydrogen 8. You can write as carbon 5, hydrogen 8, and as structural formula which you can see on this slide. Menthol, terpenhydrat, validol are monocyclic terpenoids. Terpenoids has in the structure, except carbon and hydrogen, has oxygen. For example, menthol, terpenhydrat, validol, which have oxygen in the structure also. And bicyclic terpenoids, there are camphor, bromcamphor, sulfocamphoric acid. And except these terpenoids, which have 1 or 2 cycles, there are other terpenes which have different numbers of carbon and hydrogen. For example, monoterpenes have 10 carbons and 16 hydrogens. Sexquiterpenes have 15 carbons and 25 hydrogen. Diterpenes have 20 carbon and 32 hydrogens. Triterpenes have 30 carbons and 48 hydrogens. And we can see the polyterpenes, the structure of polyterpenes, carbon 5, hydrogen 8 isoprene in N. We take in brackets and write N, polyterpenes. Terpenes may have acyclic and cyclic structure. Cyclic terpenes may have mono and bicyclic structure. Monocyclic terpenes. Monocyclic terpenes are menthan derivatives. And you can see the structure of menthan. Menthan has no hydroxyl group in the structure, which has menthol in its structure. In medicine practice use levomenthol, and menthol we can say also levomenthol, because levomenthol is natural menthol, and is used from different kind of mentha plants. For example, mentha piperita, mentha arvensis, and it's includes in essential oil of mentha, of this plant. Menthol had this structure, and the chemical name of menthol, L2-isopropyl, you can see isopropyl radical, 5-methyl-cyclohexanol. In medicine practice, use also dementhol and racemic menthol, mentholum racemicum, Latin name mentholum racemicum, DL menthol, and DL menthol, the chemical name, the L2-isopropyl 5-methyl-cyclohexanol, also the cyclohexanol 1. The L-menthol, dementhol, and L-menthol are used in medicine practice. For example, the L-menthol, racemic menthol, are used as outside drug form. The next preparation, validol. Validol had in the structure menthol and methyl ether of isovalerianic acid. You can see mixture menthol and methyl ether of isovalerianic acid. You can see mixture methyl ethers of isovalerianic and methyl ethyl acetic acid. Terpenum hydratum. Terpenum hydratum, you can see the chemical structure of terpene hydratum. It's para-menthandiol 1,8. Terpenum is received from terpentine, in which the main compound pinene. And you can see as from the pinene with sulfuric acid, we receive this sulfuric derivatives of pinene, and when you hydrolyzes in the present sulfuric acid, we receive terpene, and we receive terpene hydrate. When we add water, terpenum hydratum. There are different methods of receiving menthol. Before I said menthol received from the different kind of mentha plant, mentha piperita, mentha arvensis, which have 30 and 40% of menthol. But there is borat method receive of menthol when we add boric acid of boric anhydrate to menthol, and we receive methyl ether of boric acid, and when distillation we receive menthol, free menthol. In industry we receive racemic menthol, the L menthol, from metocresol. You can see the structure metocresol when reacts with isopropyl chloride in the present aluminum chloride, we receive thymol, and when reductation thymol we receive menthol. And you can see the difference between the thymol and menthol, that thymol had in the structure double bonds, but menthol has no double bonds in its structure. Menthol has free asymmetric carbon atoms. Therefore, 8 optic active isomers. When we write 2 in the level 3, it means 8 optic active isomers. L isomer, medicinal menthol. In oleum mentha there is 20%. L menthol, from N menthol also we can receive L menthol after reductation, and you can see from this order when we reduction L menthol, and you can see keto group in this structure. When reduction we receive L menthol, and you can see asymmetric carbon atoms, and I show it as stars. As stars in this position which position carbon which are asymmetric carbons, and we also receive menthol from thymol when reduction thymol. Okay, from menthol and thymol. Menthol has mentha smell, a colorless crystal with a cold taste. Menthol from eutectic mixtures with camphor, chloral hydrate, phenol, resarsenol, and thymol. And you can see that what does it mean, eutectic mixture? When we take 2 soft powder and when we mix each other, we receive a liquid mixture, and it's liquid mixture called eutectic mixture. Menthol is very little soluble in water, very easy soluble in 95% alcohol, ether, acetic acid, and oleums. When we speak about identification, we can see that when oxidized menthol, for example, when we use concentrated sulfuric acid, we receive menthol, and menthol with vanillin, 1% solution of vanillin in concentrated sulfuric acid, appear yellow color. But when add 1 milliliter water, this color gets red. Thymol does not give this reaction. Melting point of this menthol 41-44 degrees Celsius. Optical density is minus 49 degree till minus 51 degree. When we speak about checking of purity, we have free checking, free tests. For example, the first test, preparation, when we dissolve in 95% of alcohol, the solution must be neutral. And the second test, preparation dissolves in acetic acid, add 3 drops of concentrated sulfuric acid and 1 drop nitric acid. Green color must not be. We determine thymol in this preparation. And the third test, when we put preparation between white pages of paper, must not be oleum spots. Assay, there are different methods. For example, chemical methods and gas liquid chromatography method. For example, acetylation with acetic anhydride in medium non-aqueous pyridine, and at the end of reaction form acetic acid. This acetic acid titrated by 0.5 mole sodium hydroxide and indicator phenolphthalein. You can see this reaction, menthol with acetic anhydride form methyl ether of acetic acid and acetic acid, and the surplus of acetic anhydride form during hydrolysis form acetic acid, and acetic acid we titrated with sodium hydroxide in present phenolphthalein. Except this method, there are other methods thermonephelometric method, spectrometric with paradimethylaminobenzyaldehyde in concentrated sulfuric acid, and in lambda maximum 545 nanometer, it's visible diapason. When we speak about using, menthol is weak antiseptic, spasmolytic, sedative, anti-inflammation, has anti-inflammatory activity, and take the pain. It includes different drops. For example, tooth drops, foam in the oleum, menthol oleum, ointment, boramenthol, menavazine, and etc. Validol colorless without menthol smell. It's oleous liquor, insoluble in water, fast soluble in alcohol. And you can see density of validol 0.894 till 0.907. And it means that this preparation we can determine by polarimetric method. When we speak about identification, we identification as menthol. All of the reaction which we use for menthol. For example, reaction with vanillin concentrated in presence of concentrated sulfuric acid, and other reactions of validol. Assay. This preparation we assay with 1 mole potassium hydroxide in alcohol solution and boil. Then surplus of potassium hydroxide is titrated by 0.5 mole hydrochloric acid until pink color disappears. Indicator phenolphthalein. Validol used as spasmolytic sedative activity, has sedative activity to central nervous system vasodilator. It's used in stenocardiac neurose conditions, in tablets, in capsules, under the tongue. When we speak about terpene hydratum without smell, these colorless crystals or crystalline powder with bitter taste. It's little soluble in water, chloroform, ether, middle in heat water, and soluble in 95% alcohol, and in heat 95% alcohol, soluble very well, very easy soluble. About when we speak about identification, when we heat this solution of preparation and add several drops of concentrated sulfuric acid, form terpeneol with very good smell. And terpeneol and eucalyptol. Eucalyptol we also know as cineol, eucalyptol. The other name of eucalyptol, cineol. Preparation with 5 drops. When we add to solution of preparation 5 drops 3% iron chloride in alcohol solution and heat in porcelain cup, form red, purple, green colors spot in different places of cup. After cool, add benzene and blue color appears. When we speak about melting point of this preparation 115-117 degrees Celsius, and for assay method we use refractometric determination. When we speak about usage, this preparation used as expectorant during sputum, phlegm, and used as tablets. When we speak about bicyclic terpenoids, we can see that bicyclic terpenoids belong camphor, bromcamphor, sulfacampharatum, acidum sulfacampharatum, or you can see acid sulfacamphoricum, and all of these preparations are derivatives of camphor, and you can see the structure of camphor. And camphor is keta derivative of camphor. You can see camphor or camphora, Latin name camphora, is derivative of keta derivative of camphor. What the difference between camphor? Camphor has no keta group in the structure, but camphor has keta group in the structure. Therefore, we give some reaction to determine keta group in this structure. Camphor has two asymmetric carbon atoms, therefore 4 active isomers. D camphor is natural camphor, L camphor, and racemic form DL camphor. You can see the structure of camphor, and you can see the chemical name of this camphor, decamphor, 1,7,7,3-methyl bicycla heptane 2-on. Brom camphor, which have the brom atom in the structure, DL, free brom, 1,7,7,3-methyl bicycla heptane 2-on. And acidum sulfa camphoratum, which has in the structure the rest of sulfuric acid, and which belong to methyl radical. Therefore, 1,7,7,3-methyl bicycloheptane 2-on sulfone 10 acid monohydride, and you can see it's used as monohydride. When we speak about receiving camphor, there are different ways to receive camphor from bornyl acetate. When we hydrolyze bornyl acetate, receive borneol, and when oxidize of borneol, receive L-camphor. From pinene, and in present different catalysator, we receive camphan, which have double bond in the structure, and with formic acid we receive bornyl formiate, and when hydrolyzed bornyl formiate we receive borneol, and at the end of reaction we receive the L-camphor. The L-camphor is racemic form or camphor. When we speak about brom camphor, when we react camphor with bromine water, at the end of reaction form brom camphor and hydrobromic acid. When we speak about identification, we determine in the meta position to double bonds to the keta group, connect aldehyde groups of different aldehydes. For example, when we react with furfurol, benzaldehyde, form different color compound. For example, blue-purple color with furfurol, or red color with benzaldehyde. When we speak about brom camphora with sodium hydroxide, in the present zinc powder form brom camphor and form sodium bromide and zinc oxide. When we speak about acidum sulfacamphoratum with 2,4-dinitrophenylhydrazine form hydrazone. You can see hydrazine connect with, instead of oxygen, connect nitrogen and form 2,4-dinitrophenylhydrazone acidum sulfacamphoratum. When we speak about assay quantitative determination, for brom camphor give Volhard methods is the back titration argentometric method of determination. When we use ammonium rhodanate as citrant, and we use as indicator iron ammonium sulfate. And first of all, we add 30% potassium hydroxide and zinc powder, and during 30 minutes form potassium bromide potassium bromide, which we determine by argentometric titration by Folhart method. And second way for camphor, the first way for brom camphor, but second way for camphor, after form oxime, and oxime form when we react with hydroxylamine hydrochloride, form oxime. We use gravimetric method. Gravimetric method it means weight method, or we use neutralization method, because at the end of reaction form hydrochloride, and hydrochloride we determine by sodium hydroxide. The third way for acidum sulfacamphoratum, because of its acid, we use neutralization method. It's neutralization method, alkalimetric method, with sodium hydroxide in water medium and indicator phenolphthalein. Camphor is a stimulator of central nervous system and cardiotonic remedy. Camphor used outside and has antiseptic action. Brom camphor has sedative action to central nervous system, and acidum sulfacamphoratum includes in the medicine form, which is called 10% sulfacamphocainum pro injectionibus, or for injection. 10% sulfacamphocaine has in its composition 49.6 gram acidum sulfacamphoratum, 50.4 gram procainum or novocainum, till 1 liter of water pro injectionibus, or for injection. You can see in this composition there is procaine, there is acidum sulfacamphoratum, acidum sulfacamphocainum, acidum sulfacamphocainum, and 1 liter water pro injectionibus. And you can see that pH of this liquor 4.2, 5.8, and this medicine form gives reaction for sulfa and keta groups, because in the structure has acidum sulfacamphoratum. And procaine also gives reaction for the primary aromatic amine, because you know that procaine, the derivative para-amino benzoic acid, and in the structure of procaine, you know, has primary aromatic amines. Therefore, gives the reaction for primary aromatic amine, namely forming azodie. About quantitative determination, when we speak about quantitative determination, for this form, 10% sulfacamphocaine for injection for injectionibus, or for injectionibus or pro injectionibus, there are two methods of assay. It's neutralization method and nitritometric method. Neutralization method, because of in the composition there is acidum sulfacamphoratum, and nitritometric method, because of in the composition there is procaine or novocaine. You know that nitritometric method, in nitritometric method, as a titrant is used sodium nitrite. As an indicator, may be used three indicators: outside, inside, and equivalent point may be determined by potentiometrically. Outside indicator, this iode starch paper. But inside indicator, tropyalin 0, and different mixture tropyline 0 with methylene red or methyl red, methylene blue with mixture methylene red. Is these indicator are inside indicators. Camphor, this sulfocamphocayne, 10% camphocayne, also used as camphor. But sulfocamphocayne soluble in water, therefore using intravenous and intramuscular. We also have in our program vitamin A, and you know that vitamin A belongs to fat soluble vitamin, as vitamin K, vitamin E, vitamin D. And vitamin A or retinol is used in medicine as different ethers, and you can see radical maybe hydrogen, maybe acetate, retinol acetate, retinol palmitate, retinol succinate, and vitamin A, the other name oxyroftol, and vitamin A has 6 stereoisomers, and transisomers is natural retinol. But in medicine practice use cis isomers also, and the alpha, beta, and gamma carotenes are provitamins of vitamin A. Alpha, beta, gamma carotenes, you can say, are prodrug. Retinol are received from fish liver. In industry, retinol is received from citral. You can see the structure citral, and from citral we received beta iodine, and at the end of reaction we receive retinol. Retinol is insoluble in water because it's fat soluble vitamin, and soluble in organic solvents. When we speak about identification, retinol acetate with sodium chloride in chloroform give blue color product with lambda maximum 630 nanometer. You can see it's visible diapason. Therefore, we can use photometric determination of retinol acetate. Also, we use thin layer chromatography method, and for assay method we use spectrophotometric determination, also in ultraviolet diapason, where lambda maximum 336 nanometer. Retinol used during avitaminose, hypovitaminose of vitamin A, and skin and eye diseases, to treatment skin and eye diseases. We also have some information about asymmetric synthesis of menthol. Before I said that menthol has 3 asymmetric carbon atoms, therefore has 8 isomers. And for enantioselation synthesis is used as catalyst, cation active BNAP, or we say norbornadiene. BNAP RH is complex of BNAP and rhodium. You can see the structure, and BNAP, RH, and plus. You can see this way of receive of menthol. You can see that the first substance myrcene, and during this reaction we use a different catalysator, and at this reaction receive isopolygol and at the end of reaction receive menthol. It's the way of receiving asymmetric synthesis. It's the way of asymmetric synthesis of menthol. There are S-binap, R-binap, and complex binap with ruthenium and rhodium. And you can see that citronellal is used in perfumery and in the synthesis of insecticide metopren. Okay, I think I give full information about the first topic, which include in the program of the third course of pharmaceutical chemistry subject, and this subject is called Pharmaceutical Chemistry 2, and we speak about adamantane derivatives, we speak about terpenoids, and I think terpenoids, and I think I think I give the full information about the analysis of this preparation, about stereochemistry problems of these stereochemistry questions, and I think we'll see soon. And the next lecture about steroidal compounds, about steroids, and thank you for attention. See you soon.